Hi there, my name is Ludmila. I'm here to introduce to you the Timetagger series by Swabian Instruments. The Timetagger is a precise system for time-resolved event counting. The electronics inside the Timetagger is designed to detect rising and falling edges in voltage patterns, which can arrive from your single-photon detectors, pulsed laser, stage of a scanning microscope, or waveform generator. Timetagger assigns a digital timestamp to every detected event. You might know such event counting systems by the name TDC for time-to-digital converter or TCSPC for time-correlated single-photon counter. I will simply call it Timetagger. The Timetagger series includes two compact standalone modules, Timetagger 20 and Timetagger Ultra. Both devices have 8 identical fully independent channels in the basic configuration. Additionally, every Timetagger Ultra can be extended to up to 18 channels simply via firmware update. Our systems are always ready to grow with your experimental needs. Timetagger uses USB to transmit all detected timestamps to your computer, where the data will be processed the way you choose. The combination of precise hardware for data acquisition and flexible software for data processing make the Timetagger one of the most powerful modern solutions for time-correlated event counting. Let's first check out the hardware specifications at our webpage, swabianinstruments.com. Timetagger 20 can transfer more than 8 million tags per second. Timetagger Ultra handles 65 million tags per second. The dead time of the input channels is only a few nanoseconds, which is faster than recovery time for most single-photon detectors. Finally, the Timetagger provides an outstanding time resolution. The electronic jitter of Timetagger 20 is 34 picoseconds, and Timetagger Ultra is below 10 picoseconds. Let me explain what I mean by the electronic jitter. Imagine that you split a square wave between two identical channels. Then you keep track of differences between the timestamps on those channels. The events will be almost coinciding with a slight uncertainty introduced by electronics. Therefore, the correlation between these channels is a peak of finite width. The electronic jitter can be defined as full width at half maximum of the correlation peak, or as its standard deviation, that is, root mean square value, RMS. Notice that we have obtained an average jitter for two combined channels. We need to divide this value by square root of 2 to get the jitter per channel. Now, how do we build the correlation between two channels? Or what if you want to measure a start-stop histogram? Or what if you want to keep track of coincidences between multiple detectors? Swabian Instruments will make your life easy with the powerful software engine of the Timetagger. Run any number of different measurements simultaneously, process the data on the fly, design arbitrary measurements, save raw time tags for post-processing, and even replay your most important data streams. Every one of our Timetaggers comes with a free software package and its regular updates. The package includes a graphical user interface realized as a cross-platform web application. It gives you an easy plug-and-play experience with the Timetagger. On the other hand, our application programming interface enables you to realize any custom measurement. The API is a broad collection of methods and measurement classes that can be used in 6 programming languages. Let's measure electronic jitter of Timetagger Ultra using the web application. Simply connect your Timetagger to your computer and run the web app. The program opens in your default browser. Now I'm going to create a Timetagger. The program shows a list of all available devices connected to my computer. I choose Timetagger Ultra. In the top left corner, we can adjust the settings. We will keep the default trigger level at half a volt. One can also define a positive or negative delay up to 1 second with a step of 1 picosecond. This is useful when you deal with cables of different length. As you already know, the default dead time is 2 nanoseconds. You can increase it, for example, if your detectors suffer from ringing or after pulsing. I will keep it at default. Finally, I enable the test signal at the channels 1 and 2. Every Timetagger has an embedded oscillator that generates a square wave. Using this test signal, we can measure the electronic jitter. Let's run the correlation measurement between the first and second channels. The bin width is our digital step along the time axis, and the number of bins is the total number of such steps in the measurement window. So, we are going to see a measurement window of 1 nanosecond. Here is the correlation peak. Notice that it is shifted from the center because of the internal propagation delay between the channels 1 and 2. We can introduce a software delay to bring the peak to the center of the image. Let's take a look at this peak in more detail. Now we can easily estimate the electronic jitter. It is below 10 picoseconds, as specified. The same measurement can be done as a simple script in your favorite programming language. In fact, the API example of the correlation class is already shown here. Let's measure the time jitter in Python. The script connects to the time tagger, enables test signal on the first and second channels, compensates for the internal propagation delay between them, and measures the correlation. These are the values for electronic jitter per channel for Timetagger Ultra. This and other examples in all supported programming languages you can find in the Timetagger installation folder. Congratulations! Now you know how to use the Timetagger. Yes, it is that simple. Swabian instruments empower you with excellent modern systems for data acquisition and processing. All our users are entitled to lifetime technical support. Therefore, they can spend their time doing groundbreaking research, be it bioimaging, material science, laser ranging, or quantum communication. We are excited to hear about your application and help you to realize your most ambitious projects. Contact us to choose the best time tagger for your setup. We can't wait to hear from you. Swabian Instruments. You count.